Have you ever looked up at the night sky and felt a sense of wonder? A feeling of connection to something ancient and vast? Well, what if I told you that connection is more real than you could ever imagine? There's a quote that perfectly captures one of the most astonishing truths ever discovered. Everything you are, your thoughts, your memories, your sense of self was once scattered dust, adrift in the void. It sounds like poetry, but it's pure science. Every single atom in your body, the calcium in your bones, the iron in your blood, was forged in the fiery heart of a star that lived and died billions of years ago. We are literally made of stardust. But this journey we're about to take goes even deeper. It asks a question that is perhaps even more profound. We know where the atoms came from, but how did those atoms learn to think? How did the universe itself, for the very first time, become aware of its own existence? For most of cosmic history, the universe was silent. It was a magnificent but unconscious spectacle, vast swirling ocean of energy and matter, blindly following the laws of physics, completely unaware of its own breathtaking beauty. Galaxies collided. Stars were born in brilliant stellar nurseries, and black holes warped the fabric of space-time, all in perfect, unthinking silence. There was no one and nothing to witness it. Then, after an almost unimaginable stretch of time, 13 billion years of cosmic evolution, something truly extraordinary happened. On a small rocky planet orbiting an unremarkable star, matter began to wake up. Inert atoms, forged in stellar furnaces, began to assemble themselves into complex structures. Those structures became living cells. Those cells over eons formed intricate networks, creating brains. And somewhere deep within the folds of those brains, a new phenomenon flickered into existence: consciousness. For the first time, a piece of the universe began to ask questions about itself. What is this place? What am I? This is the incredible story we're going to explore, the story of cosmic self-awareness. It's the journey of the universe itself, from mindless chaos to profound comprehension. In this series, we will trace this epic story across 6 parts. We'll start at the very beginning, witnessing how the raw ingredients of life were forged in the death throes of massive stars. We'll see how these elements seeded the cosmos, leading to the formation of planets and the emergence of life-sustaining biospheres. From there, we'll explore the greatest mystery of all. How did non-living matter cross the threshold into life? And how did that life eventually develop a mind? We'll journey through the evolution of brains and the dawn of consciousness, seeing how a simple survival tool became capable of abstract thought, art, and philosophy. We'll then see how that mind, our mind, finally turned its gaze outwards, developing the tools of science to look back into the cosmos and piece together its own origin story. We are the universe's memory, its living history. Finally, we'll ask what comes next. What does the future of consciousness hold? What might the next stage of cosmic awareness look like? And what role will we play in it? Because when you strip everything else away, perhaps the ultimate realization is this: we are not separate from the universe. We are a part of it. We are the universe, finally looking back at itself, trying with all our might to understand our own story. Before life, there was only physics. Before the mind, there were only forces: gravity, electromagnetism, and the strong and weak nuclear interactions, weaving a tapestry of particles into the structure we now call the universe. Our story begins 13.8 billion years ago, in the unimaginable fireball of the Big Bang. In the first few minutes, as the universe expanded and cooled, the simplest atomic nuclei formed: hydrogen, helium, and a few traces of lithium. These were the primordial elements. But they were just dead matter, incapable of thought, incapable of complexity. For hundreds of millions of years, the universe was little more than a dark, expanding fog of hydrogen gas. Then, gravity, the universe's master sculptor, began its grand experiment: us. It started pulling that gas together, compressing it under its own immense weight until the first stars ignited. Inside these stellar furnaces, a kind of cosmic alchemy began. Hydrogen fused into helium, helium into carbon, oxygen, nitrogen, and all the way up to iron. Each generation of stars became a forge, creating the periodic table piece by piece. When the most massive of these stars reached the end of their lives, they didn't just fade away. They exploded in spectacular supernova, scattering their newly forged elements across the cosmos. This cosmic dust seeded entire galaxies with the raw materials for planets and, ultimately, for us. We call this process cosmic chemical evolution, the slow, patient transformation of simple matter into the complex chemistry that would one day make DNA and neurons possible. Think about that for a moment. Every single element essential to biology, the carbon in your cells, oxygen you're breathing right now, the iron in your blood, the calcium in your bones, every one, was born in the heart of a star that lived and died long before our Earth even existed. This isn't a metaphor, it's physics. You are quite literally made of stardust. As galaxies like our own Milky Way formed and matured, they became vast ecosystems of creation and destruction. Giant molecular clouds, enriched by past supernova, condensed to birth new generations of stars. Within these stellar nurseries, microscopic dust grains formed, tiny specks of silicates and carbon compounds. These weren't just cosmic debris, they were the seeds of future planets. Our Milky Way is one such nursery, a sprawling spiral galaxy with over 100 billion stars, each a potential sun for worlds of its own. Then, about 4.6 billion years ago, in a quiet, unassuming arm of the Milky Way, one of those stars was born, our sun. Around it, a disk of gas and dust began to swirl, a leftover from its formation. Over millions of years, through countless collisions, dust grains stuck together, forming pebbles. Pebbles clumped into rocks, and rocks crashed together to form planetesimals, the building blocks of planets. Out of this chaotic cosmic dance, a system of worlds emerged, and among them was Earth, a small, rocky planet, perfectly placed and rich in the elements of life. Here, for the first time we know of, chemistry was about to cross the threshold into biology. On the young Earth, the stage was set. Its oceans were a complex, bubbling soup of molecules. Energy was everywhere. Lightning strikes crackled through the atmosphere. Volcanic vents superheated the waters, and intense ultraviolet light from the young sun streamed down. This energy powered a frenzy of chemical reactions, creating amino acids, nucleotides, and lipids, the fundamental building blocks of all living systems. Experiments like the famous Miller-Urey experiment in the 1950s proved it was possible. They recreated the conditions of early Earth in a lab, and just by adding a spark of energy, they watched as these basic building blocks of life formed spontaneously. But chemistry alone wasn't enough. Having the ingredients is one thing, making them come alive is another. These molecules had to find a way to store information, to replicate themselves, and to evolve. They had to become something that could adapt and survive. And that's where the story takes its most mysterious turn, from simple chemistry to the dawn of biology. Somewhere on that ancient Earth, perhaps in the crushing darkness of a deep-sea hydrothermal vent, or a sun-baked tidal pool, a molecule emerged that could do something miraculous. It could make copies of itself. This first replicator, perhaps a primitive form of RNA, wasn't perfect. Its copies sometimes had tiny errors or mutations, and in those imperfections, evolution found its foothold. This great transition, from inanimate matter to the first self-replicating life, remains one of the most profound and unsolved mysteries in all of science. It marks the moment when the universe began to organize itself in an entirely new way, a way that could eventually lead to awareness, to thought, to us. From this single origin point, the engine of natural selection took over. Acting over billions of years, it would turn those simple replicators into the first cells, cells into complex organisms, and organisms into conscious beings capable of looking up at the stars and wondering where they came from. When the first stars ignited, the universe created light. When the first living cell emerged, the universe created information. When the first self-aware mind contemplated the cosmos, the universe created meaning. All three are simply transformations of the same fundamental material energy. And matter, guided by physical laws that, for reasons we still don't fully understand, allow for ever-increasing complexity. The great astronomer Carl Sagan summarized it beautifully. We are a way for the cosmos to know itself. But before consciousness could truly bloom, it needed a stable home. It needed worlds capable of sustaining the delicate balance of chemistry, energy, and time required for life to not just begin, but to flourish. And that leads us to our next chapter, the search for other worlds like our own, scattered among the stars. Thank you so much for joining me on this journey through cosmic history. Imagine a cosmic lottery with billions and billions of tickets. Most are duds, but a precious few, are winners. These winning tickets aren't for money, they're for life itself. This is the story of how the universe arranges its raw materials into worlds, capable of sustaining life, how cosmic chemistry becomes a living ecosystem. Across the Milky Way, as stars ignite, the leftover disks of gas and dust around them begin to clump together. Gravity and countless collisions sculpt these disks into families of planets, moons, and asteroids. But for a planet to hit the jackpot, it needs to land in a very specific place. The Goldilocks zone. Not too hot, not too cold, but just right for liquid water to flow on its surface. But temperature is just the start. The checklist for a habitable world is long and demanding. You need a stable, long-lived star, a magnetic field to act as a shield against deadly radiation, a protective atmosphere to trap heat and allow chemistry to happen. And of course, the right ingredients: water, carbon, and other complex molecules. Perhaps most crucial of all is geological activity, volcanoes and shifting continents to recycle nutrients and keep the climate from going off the rails. When all these conditions align, something incredible happens. The planet can maintain a state of constant dynamic imbalance. This disequilibrium is the engine of life. It's the spark that prevents stagnation and keeps energy flowing. It's easy to forget that just a few decades ago we had no proof of any planets outside our own solar system. Then, in 1992, astronomers found the first exoplanets orbiting a pulsar-dead star hosting ghostly worlds. 3 years later, the discovery of a gas giant named 51 Pegasi b, orbiting a sun-like star, opened the floodgates. Astronomy was never the same. Since then, powerful telescopes like Kepler, TESS, and now the James Webb Space Telescope have revealed a staggering truth. Planets are not the exception, they are the rule. We've now confirmed over 5,500 exoplanets, and scientists estimate there are tens of billions in our galaxy alone. Many of them are Earth-sized, and many orbit within their star's habitable zone. The universe, it seems, might be filled with countless worlds where Stardust, just like ours, could have awakened. Among all these potential worlds, Earth remains our one and only confirmed example of a biosphere. Planet-wide web of life, powered by geology, chemistry, and sunlight. To understand what we're looking for out there, we first need to understand the journey of our own home. Let's rewind the clock. Earth began as a molten hellscape. Heavy elements like iron sank to form the core, while lighter materials floated to the surface, forming a crust. For millions of years, it was pummeled by asteroids, which, ironically, delivered the water and organic compounds that would later seed life. The early atmosphere was a toxic soup of carbon dioxide, methane, and ammonia and oxygen to be found. But this hostile mix may have been the perfect chemical factory for life to begin in the early oceans and around volcanic vents. And then it happened. Sometime between 3.8 and 3.5 billion years ago, the first microbes appeared. Life got started almost as soon as the planet was stable enough to host it. For the next 2 billion years, these tiny organisms ruled the world. Then came the game changer, around 2.4 billion years ago. A type of bacteria called cyanobacteria evolved a new trick: photosynthesis. They began breathing in carbon dioxide and releasing oxygen as waste. This great oxygenation event was a catastrophe for much of early life, but it completely transformed our atmosphere and paved the way for creatures like us. Finally, about 600 million years ago, cells started working together, forming the first multicellular organisms. This cooperation led to the Cambrian explosion, a sudden burst of evolutionary creativity where life diversified into an incredible array of complex forms, including the first animals with eyes, limbs, and nervous systems. Each of these steps was a monumental leap in complexity, from inert chemistry to biology, from single cells to complex networks. And each leap required billions of years of planetary stability, a gift that Earth provided in spades. This brings us to a great scientific debate. On one side is the principle of mediocrity. It argues that Earth is nothing special. Given the sheer number of stars and planets, life should pop up frequently, wherever the conditions are right. This view paints a picture of a cosmos teeming with life. On the other side is the rare Earth hypothesis. This idea suggests that while simple microbial life might be common, complex life, like animals and plants, is extraordinarily rare. It argues that Earth's habitability is the result of a long and improbable chain of cosmic luck. Stable orbit in a quiet part of the galaxy, a large moon to stabilize our tilt, a giant like Jupiter to shield us from impacts, and active plate tectonics to regulate our climate. Whichever idea turns out to be right, they both highlight the same incredible fact. A habitable world is a precious and hard-won prize, and the search for these prizes is on. We see tantalizing hints of potential biospheres, even in our own solar system. Mars once had rivers, lakes, and maybe even an ocean. If life ever started there, it might still be hiding underground. Jupiter's moon Europa and Saturn's moon Enceladus hide vast salty oceans beneath their icy shells. In fact, Enceladus has been seen spraying plumes of water vapor containing organic molecules into space. And Saturn's largest moon, Titan, with its methane lakes and thick carbon-rich atmosphere, looks like a prebiotic Earth in a deep freeze. And now, with the James Webb Space Telescope, we can analyze the atmospheres of distant exoplanets, looking for biosignatures, the telltale chemical fingerprints of life, like oxygen and methane existing together, or even pigments from alien photosynthesis. Each discovery brings us closer to answering that ancient, profound question: are we alone? But finding life elsewhere would still point back to the same cosmic story. It's a story of matter striving for complexity, organized by the same universal laws. A habitable world isn't just a place. It's a dynamic, interconnected system. Here on Earth, the atmosphere, oceans, continents, and all living things are locked in an intricate dance of feedback loops that maintain stability. Photosynthesis creates oxygen, while volcanoes release carbon dioxide. Oceans move heat around the globe, moderating the climate. Life itself literally reshapes the planet. This concept is sometimes called the Gaia hypothesis, the idea that our planet behaves like a single self-regulating organism. As Earth's ecosystems grew more complex, evolution became a planetary engine of innovation. It invented eyes for seeing, wings for flying, and neurons for thinking. Fueled by the sun's energy, life built more and more intricate structures, creating pockets of order and complexity in a universe that otherwise tends toward disorder. This relentless climb up the ladder of complexity, over billions of years of planetary and biological evolution, eventually led to something utterly unprecedented. A piece of the universe that could look back at itself and wonder how it all came to be. And that transformation from a living planet to a thinking species is where our story will go next. We've journeyed through the cosmos, from the Big Bang's first flash to the formation of stars and planets. We've seen how lifeless chemistry on a young Earth gave rise to the first living cells. But somewhere along that incredible journey, something truly extraordinary happened. Life crossed an invisible threshold, stopped just reacting to the world and started experiencing asterisk. For billions of years, life was a beautiful, intricate dance of molecules, a relentless push for survival. But then, slowly, gradually, something new flickered into existence: awareness. Eyes that once just detected light began to truly see asterisk. Brains, these new, complex networks of cells, began to dream. And for the very first time, in a quiet corner of the cosmos, the universe felt something. This is arguably the deepest mystery in all of science. How does inanimate matter become a thinking, feeling mind? It's the ultimate crossroads where physics, biology, neuroscience, and philosophy all meet, staring at a question that no single field can answer on its own. How does the stuff of stars learn to wonder about the stars? On the surface, the answer seems simple. Consciousness comes from brains, right? These incredibly complex organs, with their billions of neurons firing electrical and chemical signals, create our thoughts, feelings, and perceptions. But when you dig a little deeper, that explanation feels incomplete. A neuron is just a cell. A cell is just a collection of atoms. So how do you get from a bunch of atoms firing in a specific pattern to the rich, inner experience of seeing the color red, hearing a piece of music, or feeling a sense of joy? This jump from physical processes to subjective experience is what philosopher David Chalmers famously called the hard problem of consciousness. It asks the fundamental question: why does all this brain activity feel like anything at all from the inside? Why isn't it all just dark, silent computation, like a sophisticated computer processing data? Science can map which parts of the brain light up when you see a face or make a decision, but it can't explain why that electrical fizz gives rise to an inner world. It's the mysterious gap between the brain and the mind, between function and feeling. To even begin to unravel this, we have to stop thinking of consciousness as a magical switch that suddenly flipped on. Nature doesn't work like that. It builds, step by tiny step, over immense timescales. The first simplest nervous systems appeared over 600 million years ago. Over eons, these simple nerve nets evolved into centralized hubs brains that could process information from the world and guide an animal's actions. Think of it as an evolutionary ladder of awareness. At the bottom, you have single-celled organisms that can sense light or chemicals and move away from danger. Very primitive form of awareness. Then you get early animals with nerve nets to coordinate their bodies. Vertebrates evolved brains that could form memories and predict what might happen next. Mammals added deep emotional centers and complex social intelligence. And finally, humans developed language, abstract thought, and self-reflection, the incredible ability to think about our own thinking. So maybe consciousness isn't a single thing, but a spectrum. It's the universe slowly refining its ability to process information, a natural result of evolution's relentless drive toward greater complexity and adaptability. This brings us to one of the most exciting ideas in modern science: the connection between consciousness and information. In physics, everything in the universe, from an atom to a galaxy, can be described in terms of information, its state, its properties, its patterns. Life itself is an information processing marvel. DNA is a library of genetic information. Your brain is a library of your life's experiences. Our culture and languages are vast stores of collective information. The legendary physicist John Wheeler even proposed a radical idea he called from bit. He suggested that the fundamental stuff of reality isn't matter or energy, but information itself. If that's true, then maybe consciousness, the ultimate processor and interpreter of information, is woven into the very fabric of existence. Building on this, neuroscientist Giulio Tononi developed the Integrated Information Theory, or IIT. It proposes that we can actually measure consciousness based on how much information a system can integrate or bring together into a unified whole. According to IIT, consciousness isn't an all-or-nothing deal. It's a gradient. A simple organism might have a tiny flicker of it. A complex brain like ours has a lot. This theory suggests that consciousness isn't some rare accident. It's a natural property that emerges wherever information becomes sufficiently complex and integrated. And that leads to a mind-bending question. If consciousness arises from complex, integrated information networks, what about the universe itself? It's the most vast and interconnected network we know. A web of particles, forces, and galaxies all interacting with each other. Could the universe, as a whole, possess some form of proto-consciousness? This isn't mysticism. It's a serious philosophical idea called panpsychism. It doesn't mean your pet rock is thinking deep thoughts. It suggests that a very basic, primitive form of feeling or experience might be a fundamental property of matter itself, just like mass or charge. And as matter organizes into more complex systems like brains, this primitive consciousness scales up into the rich awareness we know. If this is true, it solves the hard problem. Consciousness doesn't magically appear from nothing. It's been there all along, in a simple form, and evolution just amplified it. It's the profound idea that the universe is on just a stage for consciousness to appear. On it's the very thing that is slowly waking up. Even the strange world of quantum mechanics seems to hint at a deep link between the observer and the observed. The observer effect shows that the state of a quantum system can change just by being measured. This led some early pioneers of physics to wonder if consciousness itself plays a role in turning quantum possibilities into concrete reality.
Ow.
Most physicists today see this as a feature of the math, not proof of a cosmic mind. But the parallel is fascinating. Both quantum physics and consciousness show us that the world isn't just something we passively watch. Our participation seems to matter. Another way to think about this is to see consciousness as a kind of phase transition, like water turning into ice or steam. When a system like the universe reaches a certain level of complexity, a new property can suddenly emerge. In this view, self-awareness is an inevitable outcome of evolution. Just as stars are the universe's natural engines for creating light, maybe minds are the universe's natural engines for creating reflection. It's the cosmos folding back on itself to know itself. But even with all these incredible theories, we're left with the core mystery, the raw feeling of experience. Science can't yet explain what philosophers call qualia, the subjective quality of redness, the feeling of warmth, the taste of chocolate. These experiences are the most real things in our lives. In fact, your consciousness is the only thing you can be absolutely certain exists. Everything else, the stars, the screen you're watching, the world around you, is an experience happening asterisk with an asterisk. It is the light by which everything else is seen. And that light, that very awareness, is made from the same atoms forged in the hearts of dying stars billions of years ago. So let's step back and look at the big picture. The universe begins and creates matter. Matter organizes into life. Life evolves complex brains. Those brains develop minds. Those minds become conscious and start asking questions, like where did all this come from? In that moment, the loop closes. The universe, through us, becomes aware of itself. As the physicist Brian Cox beautifully put it, we are the cosmos made conscious, and life is the means by which the universe understands itself. In the grand 13.8 billion year history of the cosmos, our self-awareness is just a tiny recent flicker. But in that flicker, something magnificent happens. The universe gets to reflect on its own beauty, to ponder its own mystery, and to tell its own story. And that is the most astonishing chapter in the cosmic tale yet. Have you ever stood on a quiet hill at night, looked up at the stars, and felt a profound sense of wonder? In that moment, something extraordinary is happening. It's not just you observing the cosmos. It's a piece of the universe made from ancient stardust, looking back at itself, trying to understand its own vastness. You aren't just asterisk and asterisk the universe. You asterisk or asterisk the universe, and through you it becomes self-aware. Our planet Earth is unique, not just because it teems with life, but because that life, through us, has reached a point of self-reflection. Every thought you have, every scientific equation we solve, every piece of art we create, it's all the planet thinking. Earth has evolved from a purely physical system of rock and water into a cognitive one. It is quite literally a self-observing planet. The biologist Julian Huxley put it beautifully. Man is that part of the universe which has become conscious of itself. But how did a planet learn to think? To understand this, we have to look at Earth's great evolutionary stages. First came the geosphere, the physical planet itself. Rocks, oceans, and atmosphere. Then, life emerged, creating the biosphere, the intricate, interconnected web of all living things. But over millions of years, that biosphere produced something entirely new, intelligence. When intelligent beings started sharing ideas, building cultures, and creating knowledge, another layer formed. Thinkers like Pierre Teilhard de Chardin called it the noosphere. From the Greek word nous, meaning mind, the noosphere is the planet's thinking layer. It's the sum total of all human communication, memory, art, and science, collective consciousness enveloping the globe. These three spheres, geosphere, biosphere, and noosphere, aren't separate. They are nested, with each one growing from the one before. The noosphere is simply the biosphere reflecting on the geosphere. Its life finally becoming aware of its planetary home. The journey to this awareness is ancient and deep. Long before humans, the universe was already beginning to glimpse itself through many different eyes. Dolphins recognize their own reflections. Elephants appear to mourn their dead. Crows and ravens can plan for the future. These are the early flickers of cosmic self-awareness. Then, about 200,000 years ago, came the human leap. Asterisk Homo sapiens asterisk emerged with brains capable of symbolic thought. We developed language, art, and shared stories. We didn't just live in the world. We began to record it, to interpret it, to ask why. This curiosity led to the agricultural and scientific revolutions, where humanity learned to shape its environment and systematically study nature. When Galileo pointed his telescope at the heavens, It was Earth itself, through his eyes, finally observing its own cosmic origins. Each of these steps deepened the universe's self-reflection, but perhaps the most profound moment of all came in 1972, when the crew of Apollo 17 took the first full photograph of Earth from space, the blue marble, the loop closed completely. For the first time, the planet, through human technology, looked back at itself. That single image of our world floating as a fragile, vibrant sphere in the black void changed everything. Humanity saw its home not as a collection of divided nations, but as a single, interconnected living system. Astronaut Bill Anders, who took the famous Earthrise photo, said, "We came all this way to explore the moon, and the most important thing is that we discovered the Earth." This was a moment of planetary self-recognition. For billions of years, matter had just existed. Now, through us, it knew that it existed. With the rise of civilization, Earth's awareness began to grow exponentially. We invented writing, allowing knowledge to accumulate beyond a single lifetime. We built libraries, creating a collective memory. Today, we have the internet. It's more than just a tool. It's the latest and most powerful manifestation of the noosphere. It's a global brain. It's a self-organizing web of information where billions of individual minds connect and exchange ideas instantaneously. Through this planetary nervous system, Earth thinks, remembers, and even dreams. But this incredible self-awareness comes with a heavy price and a profound responsibility. We have become a geological force, powerful enough to change the climate, the oceans, and the very chemistry of our atmosphere. We've entered the Anthropocene era defined by human impact. We are the first species in Earth's history capable of understanding the delicate systems that sustain us. And therefore we are the first species capable of consciously destroying them. Carl Sagan captured this paradox perfectly when he described Earth as a very small stage in a vast cosmic arena. He saw our planet from afar as a pale blue dot, and in that perspective, he noted that there is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. Yet on that tiny world is everything that can know, everything that can wonder, everything that gives the universe meaning. If we extinguish ourselves, the cosmos might lose one of its only known ways of perceiving itself. The biosphere and our consciousness are completely intertwined. One cannot exist without the other. When we cut down a rainforest or pollute an ocean, we aren't just harming other species. We are damaging the very planetary network that gave rise to thought. We're tearing out pages from the only book the universe has written about itself. From this perspective, protecting the environment isn't just about survival. It's about preserving cosmic awareness. It's about protecting the only known mirror the universe has to look into. This realization marks the dawn of what could be called the Age of Awareness, an era where intelligence must evolve to become wise enough to ensure its own survival. When we map the stars, build particle accelerators to probe the fabric of reality, or dive deep into the oceans, we are not outsiders studying a foreign object. We are the universe examining its own structure. Every scientific discovery is an act of cosmic self-recognition. In this sense, our quest for knowledge isn't just a human invention. It is a cosmic instinct, the fundamental drive of the universe to understand itself. From the perspective of physics, consciousness is an emergent phenomenon. But from the perspective of meaning, consciousness is the universe's way of finally saying, "I am." So when we look at our small, fragile planet suspended in a sunbeam, we are witnessing the culmination of 13.8 billion years of cosmic history. Hydrogen from the Big Bang was forged into carbon inside stars. That stardust formed a planet, which gave rise to life, and eventually to a mind that could look back and understand its own origins. We are not separate from the story of the universe. We're the chapter where the story becomes self-aware. As the geologist Robert Hazen said, "The cosmos didn't know it was evolving until we appeared." This is Earth's greatest transformation. It's no longer just a planet orbiting a star. It's a planet that knows it orbits a star. And through that knowing, we carry the immense privilege and the profound responsibility of being the universe's conscious self. When you look up at the night sky, what do you see? Stars, planets, galaxies? Now, imagine stepping back, further and further, beyond our solar system, past the Milky Way, until our entire observable universe is just a point of light. From that vantage point, you might see something truly astonishing, a tiny, pale blue dot, where the cosmos itself is waking up. This isn't just poetry. It's a literal description of what's happening right now inside you. As you watch this, photons that have traveled for millions, even billions of years are hitting your screen, then your retinas. They trigger a cascade of neural signals, and in a flash of incomprehensible complexity, they become thoughts, feelings, understanding. This very act, the universe observing itself through a conscious mind, might be one of the rarest and most profound events in existence. At its heart, the story of humanity is the story of awareness unfolding. Think about it. For billions of years, the universe expanded, stars formed and died, planets took shape, but it was all just silent physical process. Then, on this small rocky world, something incredible happened. Within the brain of an ape, a neural circuit sparked into a new kind of loop. The loop of self-reference, single world-changing thought. I am. That one realization ignited a chain reaction. It was the Big Bang of cognition. Suddenly, we had language to share our thoughts, art to express our inner worlds, and mathematics to describe the patterns we saw around us. Evolution was no longer just a slow, biological grind. It became cultural, intellectual, and technological, accelerating at a breakneck pace. When our earliest ancestors stared at the stars, they didn't have telescopes or complex physics. But they were doing the exact same thing we do today, trying to make sense of it all. Their myths about the constellations were our very first cosmologies. Our first attempts to answer the question, where are we, and what is this place? Then came the great thinkers who began to peel back the layers of myth to find the machinery of reality underneath. People like Thales, Copernicus, and Galileo. With each new discovery, the circle of what we knew expanded, and the realm of the purely unknown shrank just a little bit more. They weren't just discovering the world. They were refining the universe's ability to understand its own laws. Fast forward to today, and science has become the ultimate tool for cosmic self-reflection. Our telescopes are extensions of our eyes, allowing us to see back to the dawn of time. Our particle accelerators are extensions of our curiosity, letting us probe the very building blocks of matter. And neuroscience has become the universe holding up a mirror to its own consciousness. This brings us to one of the most profound intersections in all of human thought, the meeting of cosmology and neuroscience. On one side, cosmologists ask, how did the universe begin? On the other, neuroscientists ask, how does awareness begin? And in the space between those two questions, a beautiful symmetry appears. Both fields are studying the magic of emergence, the process where simple rules and simple components give rise to breathtaking complexity. The early universe was simple, a hot, dense soup of fundamental particles. But from that, atoms, stars, and vast galaxies emerged. Early Earth was simple, a soup of amino acids and organic molecules. But from that, cells, organisms, and entire ecosystems emerged. And consciousness follows the same pattern. The early mind was simple, reflex, instinct. But from that, memory, imagination, abstraction, and finally, self-awareness emerged. It's a universal pattern, a ladder of complexity stretching from quarks all the way to consciousness. Is this just a cosmic accident? Or is matter somehow wired to become aware? That remains one of the greatest questions we can ask. Great astronomer Carl Sagan famously said, "We are a way for the cosmos to know itself." And he didn't mean that as a metaphor. The calcium in your bones, the iron in your blood, every single atom that makes up your body was forged in the heart of a star that lived and died billions of years ago. So when you have a thought, when you feel a sense of wonder, when you ask a question about the stars, you are literally stardust, reflecting on its own cosmic origin story. You are the universe, experiencing itself. And this process of self-discovery is still accelerating. Through artificial intelligence, we are creating new forms of non-biological thinking, amplifying the universe's ability to process information. With telescopes like the James Webb, we are extending our senses across unimaginable distances of space and time. And then there's SETI, the search for extraterrestrial intelligence. This project poses one of the most haunting questions of all. Are we the only ones? Is this flicker of self-awareness in a quiet corner of the Milky Way the only place the universe has woken up? After decades of listening, the cosmos remains silent. But the search itself is profound. It's an admission that consciousness isn't just a biological curiosity, it's a cosmological phenomenon, something so precious, it's worth searching the entire galaxy for. From the firing of neurons in your brain to the collision of galaxies billions of light years away, the universe is a symphony of repeating patterns, networks, feedback loops, emergence, and transformation. The human brain doesn't look like a galaxy, but it operates on similar principles. Both are networks. Both create complex behaviors from simple interactions. Both can learn and evolve. In a way, our entire civilization is like a single neuron in a vast galactic brain. We are a tiny node, but we are capable of sending out a signal, a message of our existence that could one day connect with others across the void. By studying the universe, we learn about ourselves. By studying ourselves, our own minds, we learn about the universe. Consciousness isn't separate from the cosmos. It's a continuation of the same creative force that lights up the stars. Through us, the universe has arrived at a point where it can question its own existence, its own purpose. And perhaps that act of questioning, that insatiable curiosity that drives us to explore, is the highest and most meaningful thing that the cosmos has ever done. For nearly 14 billion years, the universe has been unfolding from the Big Bang to the birth of stars, from the formation of planets to the emergence of life and consciousness. But this story isn't over. In fact, what happens next could determine whether the cosmos continues its long journey toward awareness or slips back into eternal silence. Let's start with a simple but profound idea. The universe is still young. The Milky Way has another 5 billion years before our sun dies. Beyond that, the universe itself might endure for trillions more. This means we're witnessing just the first flicker of cosmic consciousness, a single spark in a vast dark ocean of time. Consciousness emerged once. There's every reason to believe it could evolve further. Humanity is already starting to blur the line between biology and technology. Artificial intelligence, neural interfaces, genetic engineering are pioneering new forms of information processing, new ways for the universe to think. Imagine a civilization that fully integrates biology with machine intelligence. They would be self-repairing, capable of traveling between stars, and able to store knowledge on atomic or even quantum levels. These beings wouldn't be limited by fragile, carbon-based bodies or the short lifespans that constrain biological evolution. Some brilliant minds, like the physicist Freeman Dyson, speculated that intelligent life could eventually spread throughout the galaxy. It would adapt to different environments, perhaps even manipulating cosmic structures to survive long after the stars have faded. Others, like cosmologist Max Tegmark, propose that life and intelligence are simply patterns of information. These patterns can exist in many forms, from DNA to silicon to pure computation. If that's true, then consciousness isn't just a brief biological accident. It could be the next major phase of cosmic evolution, the universe gradually waking up through the intelligent systems it creates. We might already be seeing the earliest hints of this incredible transition. Our telescopes Hubble, James Webb, the Vera Rubin Observatory are extending our senses to cosmic scales. Our particle accelerators and quantum computers are probing the fundamental realities of existence. And our global data networks, the internet, satellites, and artificial intelligences are forming a planetary nervous system. Earth, once a passive observer, is becoming an active hub of cosmic thought. If intelligence spreads beyond Earth's weather by humans, machines, or a fusion of both, the scale of awareness could eventually become galactic. Some astrophysicists have even proposed the idea of a cosmic mind. This isn't some supernatural being, but an emergent phenomenon. Picture countless intelligent civilizations exchanging information across millions of years, connected by signals, artifacts, or a shared understanding of physics. In this future, information, rather than matter, could become the universe's most dominant feature. The cosmos might then resemble a vast, distributed consciousness, a web of self-awareness stretching across time and space, even if communication between these intelligent nodes is slow. Limited by the speed of light, the information itself could outlast the stars. Freeman Dyson envisioned intelligent beings preserving themselves in the faint heat of a dying universe. thinking ever more slowly as energy dwindles, but never entirely ceasing to exist. Others imagine intelligence finding ways to manipulate dark energy, create artificial universes, or even re-engineer the laws of physics themselves. Of course, these are highly speculative visions, but they point to a fundamental truth. Once consciousness emerges, it tends to expand. And if the universe has a natural tendency toward complexity, as its history suggests, then the evolution of intelligence may be its way of fighting against entropy, of preserving structure in a cosmos that otherwise drifts toward disorder. Even if humanity doesn't survive, our existence has already changed the universe. Every radio broadcast we've sent, every probe we've launched into deep space, every equation we've written, every thought we've had, all of it has become part of the universal record. Photons scatter and data drifts, but information endures in subtle traces. The universe isn't static. It remembers, in the faintest ways, the paths of the particles that have moved through it. Consciousness, whether human, alien, or post-biological, is the universe's way of recording its own history. It's the mechanism through which existence becomes aware of its own story. When we look up at the night sky, we're not just seeing stars. We're looking into the universe's autobiography. Every photon tells a tale of transformation from energy to matter, from chaos to structure, from dust to life. And in a very real sense, every conscious being is an editor of that cosmic narrative, shaping, interpreting, and adding to it. But this raises the ultimate question. Why? Why should the universe even bother becoming aware of itself? Physics doesn't require it. Gravity, electromagnetism, and the nuclear forces all work perfectly fine without consciousness. And yet here we are. Perhaps consciousness isn't a cosmic accident, but a natural phase of thermodynamic evolution, a way for matter to process information more effectively, to adapt, and to persist. Or maybe, as some philosophers and physicists suggest, consciousness is fundamental and intrinsic feature of reality, as basic as space and time. In the theory of panpsychism, every particle holds a tiny glimmer of experience which, through complex organization, grows into self-awareness. In integrated information theory, consciousness arises from how a system combines and processes information, making the human brain, and potentially advanced eyes, prime candidates for awareness. And in some quantum theories of mind, consciousness might even interact with the underlying fabric of reality in ways we don't yet understand. Whatever the answer is, one fact remains. The universe produced beings capable of asking this very question. That alone is extraordinary. In the end, consciousness might be the cosmos' most improbable and beautiful experiment matter, learning to look inward, to dream, and to question its own existence. We are, as Carl Sagan famously said, star stuff contemplating the stars, but we're more than that. We are the mechanism through which the universe has learned to wonder. From hydrogen atoms to human minds, from chemical reactions to self-awareness, every stage of this evolution has been a continuation of the same cosmic process: the rise of complexity, the emergence of pattern, and the growth of meaning. And perhaps, billions of years from now, when the last stars fade and the cosmos grows cold and dark, some echo of this awareness will remain. A final whisper in the void, reminding whatever follows that once, for a time, the universe knew itself. From stardust to consciousness, from chaos to curiosity, this is the story of the universe becoming aware that it exists. And through us, that awareness continues. Thank you so much for joining me on this journey through the cosmos. If you enjoyed this exploration of consciousness and our place in the universe, please consider liking this video and subscribing for more deep dives into science and philosophy. We'd love to have you as part of our community. Till next time, keep looking up.